have not done it, please do it. It's very, very important problem and it covers a lot of things. Okay. So previous to this topic, today we are going to start linked list. Before linked list, we have seen that linear data structure called array, which is a homogeneous collection of the data of same data types, which requires a contiguous memory location. Okay, but it also which give us the advantages of having that direct addressing. But we have also seen that we have a problem of having in the scalability, because whenever you use an array you always need to give a fixed size. Okay, but that is something which is problematic. Okay, so what happens is, because of uh, yeah, so because of certain limitation. Okay, and the another problem with the array which we have seen is of the even if your memory have enough space, then also it will not be able to honor the array request, because the memory space is scattered within the main memory. Cumulatively it can, but it will not, because the array requires the memory contiguous memory addresses. So to overcome all this problem, we have the another thing is called as linked list, or linked list, or linked list. Okay, both are things are same. Let's understand what the linked list exactly is. Okay, so hypothetically saying, this is how our memory look like. Hypothetically, I'm saying, okay, this is how our memory look like. What happens in this memory is, when you define a variable is nothing but a name given to the memory address, given to some memory address. Okay, and you try to store the value at this variable. So for example, 5. So whenever you do int x, int represents the data type and x represents the variable. Okay, so whatever the value you do, x equals to 5, it goes and store into the memory address to which we have given the x as a name. Okay, what happens with the linked list is, we modify this. We uses a user. So data types are also two types. One is called as primitive. Second is user defined. So if you are using C++ as a language, you will have the C. If you are using in C++ also, you have the concept of structure. If you are using object-oriented language, you have the concept of classes. So for linked list, we create a class. Let's say linked list node, in which I have data, and I try to store the address of the next node. Okay. Understand one thing is, this next is just a name, like a variable you have given now. It's just a name. It could be anything. You can write foo, bar, abc, whatever the name you want to give, you can give it here. Okay, that doesn't matter. So whenever you have the this as an object, for example, you do this ll node n. Okay, what happens exactly? If you look in the main memory, here a space is created for this object. It is two part. One is going to store the data, another one is going to store the address. Okay, so hypothetically it will look like this. So for example, this is going to be yours like this. Yeah, so for example, the address of this is, I'm writing the address. So the address is AB, or let's say A12. There is next one Anywhere in the memory it can present whose address is A13. It could be here also, and it could be here also. Anywhere in the memory it can be created. So let's say this is A13, this is A14, this is A15. Okay. What happens is, let's say the data is 1, 2, 3, and 4. Now, how you connect them, link them, it depends on how you store the address. So suppose I store the address of A14 here, A15 here, A13 here, and here it is null. So what does it means is your this node is linked with this node. When we say link with this node means this node is aware of this node, but this node is not aware of this node. How, when we say aware means it know the address of this node, but this node does not know the address of this, so it doesn't aware of this node. Similarly, when you say A15 is linked with this, and this is linked with this. Okay, all this linking is called as linked list. Okay, this is what we call as a linked list, and how we visualize it is like this. You have one which is connected to 3, which is connected to 2, and 2 is connected, sorry, 3 is connected to 4 is connected to 2, and 2 is connected to null. Okay, this is how you will visualize the linked list. Okay, always in the linked list we need another reference or the pointer to represent the head of the list from where the list is getting started. Okay, that is the most important part. Head or the reference from where the list is getting started. Cool. So this is we called as a linked list. So you can see that hypothetically it can be present, the nodes can be present anywhere in the memory. They are linked because we are storing the address of the data in the another data. Am I clear? Guys, am I clear?
Yeah, Nishan.
Okay. Now, another thing is there are type of linked list. Okay, they are the types of linked list. The one which we discussed just is single linked list. Similarly, there is something called as doubly linked list. Three, four, two, no. One previous here is what happens here is every node store the address of previous node and the next node. Okay, every node store the address of the previous node and the next node. So how the class or the structure look like? And guys, previous and next are the just name given by us. You can use anything. Okay, you can use anything there. So you can have class DLL node and data uh, DLL node next DLL node previous. Okay, so this is how you define it. And guys, linked list is a linear data structure, the type of linear data structure only. Okay, so you have the advantages. You can, whatever the disadvantage of array, you can have the advantage of it. Whatever the advantage of array, this is the disadvantage of linked list. Means you can't have the direct addressing possible here. Okay. So most of the problems which, see guys, one thing very clear I want to make is linked list is a simple topic if you know how to play with the pointer or the references within the linked list. Okay, so it will be very important to understand how the pointers or the references are being played within a linked list. Once you know that, then it will be very, very easy for you to understand the same thing. Okay, cool. Are we good so far? Okay. Now, once we have a data structure defined, the most important operation which we want to do is traverse the data structure. Traverse the data structure means uh, going through each and every node or every data within the data structure. Okay. So suppose I have a list like this, and guys, it's very important that we need to know the head. This piece of code I am going to write it for you. Okay, and listen to me very carefully because next time you guys have to write it. Suppose I am going to write a function who is going to print all the nodes in this linked list. Okay. At any point of time, if you don't understand anything, please let me know at this time itself. Okay. So suppose let me write the code. Why? Okay. So what I will be doing? I will be taking a temporary reference. When I do temp equals to head, it means that I am referencing this temp to the head. Okay. So both of them are pointing to temp. Okay. So both of them are pointing to the head only. Then while temp is not equals to null, what I will be doing? So I am writing system.out.println and just printing the temp dot data. Okay. Then temp, when I do temp is equals to temp dot next. It means that temp is now referencing to whatever the next is. So in place of referencing to this, now it will reference to this. Okay. So it's like similarly you do I plus plus. It's the same expression temp is equals to temp dot next does. Okay. And that's it. This is how you traverse the list. Okay. Just go through this piece of code and let me know if you have any doubt here.
Shant, what is the significance of taking a temp in this case? Ultimately, we can also deal with head, right? In the same way.
Yeah, we can do, but head I don't want to manipulate because when you do head equals to head dot next, eventually you lose the head of the original list. What if I change the while condition from this to this? Answer me in the chat. Then what happens to what will be the output? If I change my condition from that to this, what will be the output? The first problem which we are going to solve is this. Find the nth node or the kth element from the last. What happens in the linked list is most of the time between the different approaches the complexity remains same. Then we think of the better approach in terms of which we can traverse, which we can get the answer in the less number of the traversal. Okay, so suppose one approach is taking two traversal and the another approach is taking one traversal, then the second one is good. Okay, so this problem says that you have given a linked list, singly linked list. You have to find the kth element from the last. So if you have the list given like this 1, 2, 3, 4, 5, 6, 7, 8, the kth element means the third element from the last is this is the last element. This is the second last element. This is second last element, and this is the third last element. Okay. So you have to find the third last element. So that is 8. So you have to find the kth last element from the end. Okay. So can you guys think of how you can solve this? Is this problem statement clear? Take your time. As I told that between multiple approaches, if the complexity is same, then we have to look for the another things like how many times you have to traverse. Let's discuss. There are few approaches which we can solve this. First approach, you can count the, you can traverse the list and count number of nodes. You can traverse the list and count the number of nodes. So the number of nodes, let's say, is m, and the kth is the last one. Okay, so suppose total number of nodes is m. So what you will do, you make a calculation of m minus k plus 1, and you again traverse the list. Traverse the list. Let's suppose this value is something n. Traverse the list till nth node. This is one of the approach. Is this clear? How we can solve? Is this clear?
Yeah.
Okay.
Uh,
But
just one question. Like in array, we have zero. I mean, indexing starts from zero in array. In the linked list also, does it apply the same?
no.
So why
See,
are we doing the plus one?
okay. Because let's suppose you do 10 minus, take a practical example. If m is come as 10 here,
Yes.
k is 3, m minus k, if you do, you will get 7. So if you traverse the 7th node, you will reach here.
Got it.
Plus 1, you will get the 8. So you will reach the 8th. Okay. That's it. Second approach is, I will give a hint. Okay. Suppose there is a distance d. There are two participants, B and A. I want A always to be ahead of A always to be ahead of B by 2 meters. How I can make sure? I want A always to be ahead of B by 2 meters. How I can make sure? I can put a stick between them. I can put a stick between A and B of 2 meter. So what happened by the time A reaches the end, B is 2 meter away from the A. Am I correct? Suppose there is a distance D. I want A and B to cover that distance, but I always want A to be ahead of B by 2 meter. So what I did, I put a stick of length 2 meter between A and B. Okay. So what happens by the time A reaches the end, B will be 2 meter behind A. Aman, Ashwini, Asmita,
Yes, it's clear.
making sense?
It's a two-pointer approach, right?
But it's not a two-pointer. Udresh, Jayant, Gopal, just try to focus on the hint. Don't go for everywhere.
Yeah, Nishan.
Okay. So what we can do? Can we apply the same thing to the linked list? Because if you look here, the kth node from the last means I can use two references here. Okay. Okay, Soumya, two references I am using, but it is not what I have. So what I can do, I can maintain a k distance between P and Q. Okay. So by the time Q reaches the end in the linked list, P will be at the kth distance from the end. So P will give you the kth node from the end. Okay. So we will move we will move Q k times into the linked list, and then we will move P and Q at the same time. Okay. Is it clear? So for example, suppose this is the list we are talking about. Okay, this is the list we are talking about. So what I did, I move Q k times. Okay. Then what I did, I move both of them one at a time at the same speed. So one at a time means at the same speed I move. So by the time Q reaches the end, P will be at the K. So their distance between them is K. Is it clear, this approach? So the complexity in the first approach is order of n. The complexity in this approach is also order of n, but here you have to traverse the linked list 2 times. Here you are traversing the linked list single time. So this approach is better than the first approach. Is this clear?
Yes.
Uday, Samya, Pritam.
Yes.
Okay. Can you guys try to write a code for this so that all the cases will be covered? And you have to make sure, and while writing the code, you have to make sure that k can be greater than n. Okay.
Just one question. If k is greater than n, then should we proceed to, I mean, print the element, or should we just return nothing?
You just written the that element data.
Which element?
Kth element.
Even if it's greater than n, the length.
Oh, no, if it is greater than the n, just return -1.
Okay, got it.
Hey guys, and also one thing, it might be possible that in your assignment, some of the questions which we are already doing in the class will be present. Okay, so you have to solve them too. You shouldn't be escaping that we have already done that in the class, so no need to do it. No, I have intentionally put some of the problems from the classroom sessions into the assignments. Okay, guys, I think most of you are done. Let me share. So I want you guys to look at my code. So it's not necessary that you should follow the same thing, but it's a simple way I have written it. So you guys can have a look at it, okay, and see whether you have done the same thing or something else. This is my code. Okay. Just take 5 minutes of your time to go through this code. Okay.
Nishan, just a question here. So there are two checks, right? The first check is if head equals to null, return -1. And there is another one we see q equals to null, return -1. I think that only one can take care of both, like q equals to null will take care of even that.
This one.
Yes.
Okay. Where's the another check I have put?
First one, the first condition, if head equals to null.
That can be. It's just for the simpler understand.
So Nishant, I have one question.
Hmm.
So let's say, what if in the problem statement it is written like there will always be an element present in the linked list. So this check would not be required, right? The first one.
See, this solution will work for all the cases. Okay. So if there is at least one element in the linked list, that is fine. Let's move to the next problem. Okay. Uh, this is like middle element. Finding the middle element in the list. Okay. So suppose you have given a linked list, you have to find the middle element in the linked list. So for odd length list, there will be a single middle element like this, but even length list, there are two middle elements. So if you look at the second input, you have 2 and 3 as the middle element. Any one of them you can print, both of them are fine. But you have to write a solution in such a way that your solution should work for both the cases. Single solution can work for both the cases. Okay. So can you try to write it again? You can start with a solution which can do true traversing, but we have to look for a solution which can work in a single traversal. So think in the direction that suppose two people are running. Okay. Suppose again there is a race going on from point A to point B. Okay. Point 1 to point 2. Suppose A is running 2x kilometer or meter per hour and B is running x meter per hour. So the speed of A is twice the speed of B. So by the time A reaches the end where the B should be. Okay. By the time A reaches the end where the B should be, if you try to solve this, go with the hint, you can be able to solve in the single traversal. Okay, just think about it, and you should write the condition properly so that there should not be any null pointer exception, or it should work with all the cases, even for all the type of the linked list. Am I clear here? Aman, Ashwini, Asmita.
Nishan, here in the same program, last program, can we calculate a k like number of nodes plus divided by 2 plus 1?
Let everybody think. Okay, let everybody think. I told you na there could be multiple approaches. In the first approach, you can go with two-time traversal. Two traversal, and the second approach try to do it in a single traversal. Guys, how we can solve this? So in the first approach, what you can do is you can count the number of nodes like previous problem. Let's suppose they are m. Then what you will do? You will do m by 2. Okay. So this is always like a floor function. Okay. Floor and ceil are the mathematical functions. For example, floor of 3.2 is 3, but ceil of 3.2 is 4. Okay, that is. So what I was saying, yeah. So integers generally do the floor. So you can again traverse this again, traverse the list till this value, let's say n, till n. Next, I have given a hint to solve this. So let's see how that hint goes. Okay. So suppose the linked list is like this. Guys, I am making sense to you or it is going over the head? Aman, Gopal, Jayant, Karamveer, Sachin, Soumya, Rudresh.
Getting it, Nishan.
So 1, 2, 3, 4, 5, 6. Say no. What I can do, I have given a hint like a person is running twice the speed of the second person. So by the time the first person reaches the end, the second person will be in the middle. Okay. It's just a simple speed distance formula. Same thing we can apply here. I can take two pointers or two references called P and Q. P and Q. So P will be moving, Q will be moving twice the speed of P. Okay, means Q will be jumping 2 times. So Q will be equals to Q dot next. And P will be P dot next. So what happens is, after the first iteration, how it gonna look like? I'm using subscript to tell you the where the pointers are after this particular iteration. So after the first iteration, P will be here, Q will be here. Second iteration, P will be here, Q will be here. Sorry. Q will be here. Then P will be here in the third iteration and Q will be here. Q will become null. Okay. So you can see that where the P3 is here. This is the middle element. This middle element is the second middle element in the length of even list. Okay. Similarly, what if we have the odd list? Let's see. If we apply the same approach to the odd list, what happens in that case? Let's say this is null. Okay. So we have head here and we have P and Q here. So after the first iteration, P will be here, Q will be here. After the second iteration, P will be here and Q will be here. Okay. Now I can move more because what happens? It will fall into null pointer exception. So I have to stop it here. Okay. So this will be the middle element. We are getting this middle element. Now, is this approach clear? What we are doing? We are jumping Q 2 times. Anyone who have doubt here? Okay. Now you have to write the while condition, which make it work for both of them. Now you have to use the while condition, which will work here for both of them. Single while condition. Okay. Am I good? Gopal, Rudresh, Pritam, Sajan, Vijay,
Yeah,
Asmita?
Nisha.
Yes.
Okay. Okay, so I have my implementation with me. I want you guys to have a look at it and see. So just to have the better understanding of the pointers here or the references here, that's the only reason. Okay, so this is my implementation here. So one of the implementation is giving you the uh, first middle in case of the even list, and the second while condition give you the second middle element in the case of the even length list. Okay, just check which one is giving what. Cool. Is it clear to everyone? Vijay, Sajan, Rudresh, Gopal, Asmita, Ashwini.
Yeah, Nisha.
Yes.
Cool. So now I have a question for you guys. If this is clear, given a list, you have to tell me whether it's a even length list or a odd length list without counting the number of nodes. Can we traverse the list even if we shouldn't? Traversing is fine. The counting of number of nodes is all not allowed. The counting is also not allowed because the list can be very huge. Okay, it might be possible that the count variable itself will went into a data type overflow problem. Okay, that's why we try to avoid the counting the number of nodes in the linked list. Cool. Asmita, Ashwini, Gopal, Jayant, Karamveer, Rudresh, Rajan, Vijay. This is my code. So once you have the while loop running, after that you can check because of which condition the while loop got break. If it is because the fast pointer become nulls or fast pointer dot next become nulls. Okay, this condition cannot be also changed if you have some other while condition. Okay, so that can also go in that way.
Nishant, is it important to take both the slow and fast pointer? Even with one pointer, we can find it out, right?
This is by mistake I have put it. It's just a copy paste mistake. So, Asmita, Ashwini, Aman, Rudresh, Sajan, Ajay.
Yes. Yes, Nishant.
Okay. My next question is delete a node from a linked list. Okay. Suppose given a linked list and a value, delete the node with the value. Okay, and it is like all the elements are distinct in nature. Are distinct. Okay. So if value does not exist, output will be like yes, the delete is there. If the value not present, it will be you won't able to delete it. Is the problem statement clear? Simple. You have to delete a node whose value is equals to the value given in the problem from a simply linked list. How many extra references slash pointers need to delete the node? Okay, two. So actually, one pointer is enough to delete the node. How? Let's see. So suppose this is the list we are talking about. Okay. So then you have 5. Then you have 6, 7. Okay. Let's say till 7 only. Suppose value is given as 4. So head is here. So what I will do? I will take a pointer. Let's say P. I will check. I will iterate P. Okay, and check whether the value is equals to that or not. So P, I will move here. I will check is the value 4? No. I will come here. We will check is the value 4 here? No. I will come and check is the value 4 here? Yes. Then I will, what I will do is P dot next dot, sorry, P dot value, I will just copy it. P dot value equals to P dot next dot value. So what happens? In place of 4, 5 will be stored. Then I will be moved to the next one, P dot next. So P will be here, 6 will be stored here, 7 will be here, and at last, what you will do, you will make this as a null. Okay. So you are not playing with the addresses here, you are playing with the value. So only a one, you can delete a node using a single reference or the pointer. Okay. This problem is generally asked in the interviews. Can you guys try to write a code for this? I will give you the link. This is somewhat a bit different, okay, but not so much actually. This one. Okay, try out this. And this problem asks, actually, this problem, the same problem asked to me in Cisco interview like 4 years back, 5 years back. Okay. Guys, so I'm stopping here today. Okay. Tomorrow we will be meeting at the same time and continuing solving much complex problem in the linked list. So I suggest all of you to go through the today's recording if something is not clear or something is not need to be revisit again. Tomorrow we will discuss that also. Okay. Will that work? Gopal, Jayant, Suresh, Gagan.
Yes, Nishan.
Okay.
Okay, Nishan.
Okay, guys. Thank you.
Thank you.
Thank you.
Thanks.
Take care, guys.